Good morning, everyone. It's another day, and I've finished making my coffee, and now we can see what we're up to today. Hang out and see our ships doing some nice circles around some of these things. Yeah. So, I think we're going to go back to the unfun but also very necessary step of working on the AI. It's, conceptually challenging, and yet, I think once I spend that time and get my mind over it, get my mind through it, I guess, I think this game will start to feel a lot more potentially interesting. So, I think that's, I really enjoy systems design, and I think, one of the keys there is just like deciding what needs to exist or what doesn't exist at all. And if it does exist, how. And for me as a creator, the thing that I really enjoy is the idea of kind of these systems that end up being really interesting to engage with, but don't necessarily care that you're there or not. Like, this world is alive. It happens to be you as a participant within it, and it happens to be that participating in it is very interesting. But so it's very high and mighty aspirations that I speak to, but right now that involves the idea of a bunch of ships that are kind of going to be traversing this virtual space and having their own lives, figuring out what they're doing. Oh, now we have 4. We have 4 going around this. It is actually, it's very soothing. I don't know about you, but I think this is kind of fascinating. So, alright. So, pull up my feedback document. And I think the thing where, I did get some stuff working last time that were related to creating shooting cannons. I feel like I should keep track of what days and things I'm working on as well. So what is today? It is 4/17/20. I think AI, and the key that I want to figure out right now is turning. It's turning. It's where it needs to be. Like, because if we play this, we can see that our things know where they're trying to go. If I select this, and I look at its movement, I look at its AI control, its goal area, it's this thing over there, and I missed the one, what was just turning. Well, they're all turning left. So, clearly something is wrong in our code that they're all turning left. Turn correct direction. And hopefully it's encouraging that I'm not, that I'm struggling through this. That if you yourself, I like the the chef from Ratatouille. Anyone can cook. I think anyone can make games if they want to. And proof is, people tell me I'm pretty good at this, but oh man, just look at how long this is taking me to get through this conceptually. But I will. I do believe in myself, and so, what is involved in that, step? Why is everything turning left? And I mean, the nice thing there is, it feels like a very simple question that we can approach right now, which is just like, turn the correct direction. Everything is either turning or not turning. And all of the things that are turning left. So, guess what that means? It means it's time to look back into our code. Alright. So if we're looking into our code, then we have, I have to keep my phone out for potentially important call, so if I get distracted, that is what's going on. Alright. So I think we can pause this. Look at our ship. Think where it wants to go. Aim towards goal is -73. And that's -1 to +1. So the closer it is, 0 is that it's perpendicular to the thing it wants to go to. So I actually wonder if we should start saving this information. Right? Might be worthwhile to save this information, right? We can see here, these are the different lines that we're outputting as we're turning towards our goal. Except we've gotten farther away from our goal rather than nearer. So we've done something wrong. And let's go ahead and unpause. And now it's getting more and more and more. Okay, and now the aim towards goal. Oop. But it hit a thing. And now it's all kinds of messed up. Okay. So maybe the first thing that I actually need to do, because we still don't have island code, is I'm going to lower the number of islands to 20. Because we're not going to, I don't want to worry about island detection yet. I just want to see these things moving towards where they need to go. Okay. So this is aiming, now it's getting closer, closer. This aim towards goal. Now, okay. Yep. So as it's correcting, So I think I'm actually gonna get a notebook so I can write this stuff down, because it's I feel like it's a bad idea to be doing so much conceptual technical work in the morning. I think they often say this is the better time to do more of things that you don't have to think about. Because thinking after you've just woken up, you're operating on a lot of muscle memory, you're just kind of slowly warming up into the day. But I'm now drawing this stuff, which is even better streaming, right? And thinking about our ship and the direction it's going. And simply saying, okay, if our turn goal, just returning over and over to this function, this is that we need some sort of function. I feel pretty confident about this other stuff up to here, right? We can get our forward direction. We can get our vector to goal. So we have both of those things. We can see what our current aim is. And 0, -1 to 1. How well are we pointing? We can see the left and right side of the ship. And those things are, opposing each other. And then we're actually drawing the lines as well. And we can say our steering direction is steer direction is +1, but if aim left is more than 0, then our steer direction should be -1. So yeah. If our aim is really off, we need to turn super hard. Otherwise, turn progressively left. I wonder about this. Do we want to just be turning really hard and then think about how do we want to rethink this? Like if I could calculate my last 5 This is an interesting idea. We could say, okay, calculate my last 5 directions, and then figure out where the next time we talk I'm likely to be facing. And that could be, like, that's a really good indication of where we're going to need to be. So, you know, I think I am going to save. We have aim current, aim right, aim left. Public float aims. Equals new equals float 5. Is that right? Okay. So now we're just going to, actually I'm going to need to look this one up. C# float pop. Float array pop. Use a list. Okay. Queue, first in, first out. Or stack, last in, first out. Okay. So arrays and or indeed or more appropriate one. Okay. So I think I want to build a queue. C# queue. First in, first out collection. Several examples. Okay. So we have numbers in queue. And then create a copy, create an array twice the size, create a second queue, clear contains, removes and returns the object at the beginning of the queue. Okay. Okay. So let's try this. Okay. Queue. New queue. Float. does that also need? Okay, new queue. Yep. Okay. So in our setup, which we're actually gonna need here, I'm gonna cheat for the moment. Say aims dot nq 0f, and we're gonna do that 5 times for int I equals 0, I is less than 5, I plus plus. Okay, so let's see if this works. Is after here, aims dot nq current aim and aims dot dq, just that. Okay. All right. So if we select a ship and we have our ship AI, Q is not visible, so I can't actually see that information. I really want to see that information. Alright. Unity. Whoa, that's not how you spell any of that. Unity, Q, editor. The most common solution. Ugh. That's annoying. So this would be really nice to for int, this is the worst. I want to be able to visualize those things. Well, okay. So we're going to create the average of this. Basic values, get average of our aims. Also want to get next of our aims. So in here, I have all these functional things that I've been building. I think I might want to separate some of our like vector stuff into probably a basic vectors, and then I might separate this out into a public static class basic math. Public static get next. We're going to hand this a queue of float called queue. Oh, we need to return a float. So then we're going to go for integer. Not like that. for integer I is equal to 0, I is less than the q, that q dot length count, yeah, I plus plus. So, how do I actually get next? I'm just gonna average everything in there, right? The average change between, except if I'm gonna do that, I should only store like one or two things. So if I'm just gonna do the average of this. But that is going to involve getting the average of these things. So I think we can go ahead and get average of our float. So we have a float total equals 0f. Then we add q I. This looks real technical, right? Total plus equals q at I position. And we don't even need this because we're and then total divided by return total divided by q dot count. So then in this case, all we're doing here is actually if that average change. We're just adding that average change to our last one, right? So in this case, we're going to return get average of q. I'm going to return q at q dot count minus 1 plus get average. It doesn't like that. Can I put to an expression type q float? Can I indexing? Okay, so I guess maybe referencing a particular position needs to be. Maybe I can't actually. Maybe this is the downside of the queue. Get the determines whether an element. What's the average of a sequence of nullable double values? Q, C sharp, get last item. It's gonna be one of those things where, like, that's not the point of the queue. Yeah. So then we just need to send it the last item. And then we need to make a duplicate queue. So we're going to make a queue float temp queue equals queue. Or actually what we're going to need to do is a copy to QC sharp copy. Okay. To an existing one-dimensional array, starting at the specified array index. Okay. So the one-dimensional array that is the destination of the elements. So we can go ahead and will it let us do this? Public. No, I think we need to make an array. So float r equals new float of length q dot count. Temp q dot copy to r starting at 0. Dot length and r. Okay. So those are 3 steps. 4 steps, I guess. And here, float last. So that is one reason to save our last as a separate thing. Okay. So basic math, get average, and basic math dot get next is going to be comma current aim. I don't know if this is useful or not, even as I'm making this, but we can think about how much aiming we expect to be doing in this cycle. So let's find out. Aim average equals and aim next. float equals, I'm gonna make those public float aim average and public float aim next. Let's find out if this works. Okay. Okay. We have this thing. Aim average. Aim next. Okay. Are we saving the right thing? We might not be saving the right thing. Current aim. Which one is current aim? Okay. Current aim, current aim. Actually, and current, aim current. Oop. Aim toward goal. Aim average. But we're not using aim current at all. Okay, I'm gonna get rid of that and reset this. Okay. So, aim toward goal is almost the opposite direction. So it's gonna be one of those, probably. Let's find out. Let's confirm. Oh, or that one. Aim right is this direction, which is closer, right? Yep. Aim left, and our average aim should be getting bigger, and we're saying our aim next. Oh. That feels wrong. Oh. That would also do this, so getting next is getting the average divided by q dot count. So float no. yeah. If we're changing by like 0.3, if our average is like 0.3 and then 0.4 and then 0.5, our average would be 0.4. But actually, the next thing that we want to get is 0.6. Or do we just want the first and last divided by the change each time? That might be what we want. Should be, there's 3 here. It's changed by 0.2. Doing some really basic math. Trying to figure out what it's gonna get me. So maybe our get next should actually be last minus q dot peak, which gives us our first, is how much difference there is across this range. So we want last plus that difference divided by q dot count minus 1. So, for example, if we had a 0.2, 0.5, 0.6, and 0.5, that would be 0.3 change divided by 3 is 0.1. I think once again I'm overthinking it. I think I've really thought about doing this off stream so that the stream could be more enjoyable, but I also think it's valuable to be doing this on stream. I'm really trying to just show everything. Like, we can see that this is, that there's probably an easy way. This is the kind of thing that actually someone better with programming, better with math, would get more out of. I don't know if this is going to be useful right now. But I do think we can another thing I had been thinking about is maybe redoing this section again. Just doing that. Okay. Store aim, nope. Aims, current aim. I'm just gonna separate this stuff out into its own function. Void store aims, float, so I don't think we currently care about this right now. Okay. I don't currently care about it right now, but I do think I might want to come back to it, so. Okay. So, we're checking how hard we're steering. Then we are, so this is what we want, right? This is what we're doing. And we need to say, if we are facing the way we want, what if we just said something like, if turn goal, act, we're sending it steering goal. We're sending that every frame. And so, what if we just said our steering goal is equal to, well, our, okay. Float, steer, direction. Am I using that somewhere else? I am, yes. Float, rect is equal to turn goal plus turn intensity. Turn intensity is 0.7 and our steering goal is -4, meaning we want to turn left, but we're turning right. Turn goal is -0.4 minus 0.7. That gets us negative 1.1. On the other hand, if our turn goal is instead -0.4 and our current steering is -0.1, then that gets us a turn. Then this number is now -0.3. And if our turn goal is -0.4, but we're actually turning -0.7, then -0.4 plus 0.7 is going to be +3. On the other hand, if turn intensity is 0.7, turn goal is negative. So if we did this the other direction, turn intensity minus turn goal so we're turning that way and we want to go this way. 0.7 plus 0.4 ends up being 1.1. On the other hand, if we're facing -0.1 and we want to go -0.4, -1 plus 0.4 is 0.3, and then again -0.4 and -0.7. -0.7 plus 0.4 is -0.3. So which means we are overcorrecting. Let's try this the other way around. So our steering direction could be this. Okay, if okay. So it would be turn goal times steering correct. We're gonna try this. This is not quite gonna be what I want it to be, but I am wondering. Okay. Okay, where are you trying to go? Okay, where are you trying to go? Okay. Well, it didn't work. That's okay, though. Where is this one trying to go? It's trying to go there. Feels more correct than the other things we've been doing. Where's that one trying to go? It's trying to go there. Where is this one trying to go? I think the thing that's happening, the thing that's definitely happening, is they definitely get in these loops. I think they're just, they quickly end up overcorrecting. And then they keep going in that loop. So, I don't know if they just need to think more often. We could try that a little bit. Helmsman timer, I don't know, 0.3. 3. I do think we do want to store our last steering, though. Last steering and last aim. And I think if our direction is getting farther away, then we want to reduce our intensity. Does that feel right, though? Sure. Maybe we don't want to think about our turn intensity right now. Maybe that's actually the wrong thing to be thinking about. And just simply say, if instead we are overcorrecting, by if our aim toward goal is less than our current aim, then we've overcorrected. So we're now steering the wrong direction. That just doesn't feel right, though. If our aim towards goal is going the wrong way, I'm wondering if this is our problem. If instead we want to figure out how far off we are from 1, and what will get us there. All right. I'm gonna take a short mental break from this. Alright, so I think one, I'm going to revise this to just simply our turn goal is equal to 1 minus our aim, our current aim. So if our current aim is and then go ahead and buy the steer direction. I'm actually going to leave that as two separate lines since I may want to revise and think about this. Closer to 1, the less we need to turn. And then the turn direction we want to make is towards it's towards to their direction, left or right. So then if our turn goal is turning really hard. We're starting to face the right direction. Then if we are getting closer to the direction we want to face, if aim towards goal is more than current aim, no, is less than current aim, then we are turning towards our object, then we should be correcting downwards. Then we should be zeroing out. equal to is equal to 0f. Which would be turn intensity if we're turning left. Then we want to turn right. Else. Equals turn intensity. Oh boy. Another dark day for Randy's navigational thinking. So, probably gonna call it in a few minutes. Shy of where I would normally. I actually think being on stream is negatively influencing my ability to think about this. So, that's, sorry about that. As long as they keep continually generally turning left. Like, we're even getting, some of them are finding their ports. But the fact that they're doing this, like, overcorrection to the left is the problem. They need to be correcting back to the right. So. Funny too, because they are starting to find their ports. It's getting better. They are getting better at it, but they're not. They're doing other things that they need to not be doing. So, all right. This is a short stream today. I'm gonna go think about this off stream because as much as I wanted to show these struggles on screen, I think it's also impacting my actual problem solving. So I'd rather get through the problem sooner and move on to the next thing. But a bunch of them are finding it. So whatever else I want to say, this is getting better. We now have 18 of them that are at the port that they want to be at. Alright. Well, I'll talk to you all next Tuesday, and have a good weekend.